Today is Valentine's Day, and I'm gonna draw a heart with a robot arm to impress my date. So stick to the end if you're curious. This trick is the entry point to robot navigation and to the heart of your crush. So let's get started. I found this great article by Wolfram which describes how to draw a heart curve with sines and cosines, and a link will be in the descriptions. Our hearts come in different shapes and sizes. Some people have bigger hearts, and some have curvier ones. Let's go ahead and pick one that has the nicest curves. After that, we'll need to draw it in Desmos to confirm that we can simulate with respect to time. If you don't know what Desmos is, it is an online graphical tool and calculator. Pretty awesome. Okay, let's start by creating a variable t that represents our time. We'll go from 0.01 to 100. There isn't really a time unit as of now, we'll just call it ticks. Next, we will calculate our x and y coordinates at each given time t. This basically creates a list of 10,000 points of x and y's. So for example, at t equals 0, what would be my x and y? And at t equals 1, what would be my x and y? And so on. We just continue to plot and calculate our x and y's. Then we'll go ahead and plot our x and y coordinates. And as far as I know, our heart is red. So let's change the color really quick. Okay, now that we have our heart shape, I want to show you how to animate our path. And this will be used for the robotics end effector when it starts drawing. We'll create a slider variable called I, and let's just put 0 and 1 for now, so that we can slide around and see the variable change. And then we'll go ahead and copy our equations of x and y, except now we will replace our variable t with I. Then with the same thing, we'll go ahead and plot the x and y. Let's go ahead and turn on the label so we can see the dot. And let's test our slider, see if it's reactive. Yep, looks like our range needs to increase. So let's go ahead and change that to 2 pi, because 2 pi is a full period for sine and cosine graphs. This will ensure it covers the entire path. Alright, I changed the marker color to purple, and then let's test the slider for the animation. Looks like we're ready to program our robot. For the simulation, I am using NVIDIA's Isaac Sim. It's basically a simulation for robotics. Let me go ahead and launch the Isaac Sim and show you what it looks like really quick. Okay, we're going to open Windows. We're going to go to Example and Robotics. Underneath, we'll open this. We go to Manipulator, and we will use Follow the Target. Let's go ahead and click Load to load our robot. In this scenario, the robot will follow a target, which is the red cube. We will take advantage of this red cube and draw our heart curve around it. Once we open up the example code, let's import some libraries. We'll need NumPy for cosine and sine. We'll also need random to generate different colors. And then we'll use the debug tool to draw the path. Next, we will need to initialize some of our variables for drawing. The first one will be custom timer. Think of it as our time t, or the tick that will be increment. And then we'll need a list to store our data points, and a list to store different colors that we selected. We'll initialize the first color. After that, we'll create our drawing tool using the debug.draw. Next, in the simulation step, we'll go ahead and generate and compute the heart path. For each simulation step, we'll go ahead and increment by 1 for the timer. And let's create a scale factor for our heart shape. We'll create a time t with the scale of timer, and then basically copy and paste the equations that we have. Our new position will be the desired target plus the calculated x and y. The target, remember, is the red cube. For every 10 ticks, we will append the calculated x and y, and we will randomly select a new color for the drawing lines. I'm keeping my buffer below 70 points, otherwise it gets a little laggy. And I got some error. I was typing really fast. Let's correct my mistakes. Looks like I have a wrong parentheses here, and I misspelled target to target. Target. This function is called the draw line spline, not line splines. Okay, this one is self.draw. Okay, who took my brackets? Let's just say we got this on first try, okay? Oh yeah, let's go back and observe our scale factor for our time and x and y. If we set a very big scale factor for our time, it will basically draw it too fast that it never completes the path. And if you scale your time down, it'll basically be very, very slow. Let's go ahead and scale up our heart size. Don't we all just love someone who has a great heart for others? Just kidding. Looks like this heart is too big for this robot. Okay, I think this heart size is perfect just for you. Hey, I got one more thing to ask you. Would you be my Valentine's? Because
You're beautiful, you're beautiful, you're beautiful, it's true. I saw your